now we will see example 1.4 based on Coulomb's law. Okay, right. So read the question, children. First of all, we have to read the question and understand it properly. Write down the given data and write down what is being asked. Then only we will be able to find out the formula easily. Okay. So read the question now. Coulomb's law for electrostatic force between 2-point charges and Newton's law for gravitational force between two stationary point masses both have inverse square dependence on the distance between the charges or masses. Okay, so up to this I have read, and up to this what do we understand from the question? We know the Coulomb's formula. The Coulomb's formula is F, right? So force between two charges, Coulomb's force is Fe, and that is equal to how much, children? What is the formula? 1 by 4 pi epsilon naught Q1 Q2 divided by R square, right? So see, this Coulomb's electrostatic force has a dependency of 1 by R square, right? It is dependent on inverse of R square, right? Similarly, your gravitational force also, right? Gravitational force of attraction between two objects. What's the formula? G into mass of first object, mass of the second object divided by the square of the distance between the two objects, right? So Fg, that is the gravitational force, is also inversely proportional to R square, right? So both of them have the inverse square dependence, right? That's what they have told you in the first sentence. Now what have they asked you to calculate? Compare the strengths of these forces, right? So these forces means they have asked us to compare the strengths of Fe and Fg. Okay, so comparison means what? So A, they have asked us to compare the strength between these two forces, that is magnitudes of Fe to Fg, right? So comparison means what? We have to find the ratio, right? So that's what you mean by comparison. Compare the strength of these forces by determining the ratio of their magnitudes, right? Ratio of their magnitudes they have asked you to find. For whom and all? First Roman letter, for an electron and a proton, right? So for the first Roman letter, it is comparison between an electron and a proton. Okay, and the second Roman letter for A itself will be for two protons. Okay, so this is the first part of the question. And what is the B part of the question? B part of the question, read. Estimate the accelerations of electron and proton, right? They have asked us to calculate the acceleration of an electron and acceleration of a proton, okay, right? Due to the electrical force of their mutual attraction, right? Now we know that electron and proton, they both will be attracting each other. One is negative charge and another one is positive charge. So there will be a force of attraction between those two charges. So the electrical force is going to be the same, right? This is your Newton's third law, right? One will be exerting force on the other, and another one will be exerting its action over the other, right? So of their mutual attraction when they are 1 Armstrong unit apart, right? The distance between them is equal to how much? 1 Armstrong unit, and we now know that 1 Armstrong unit is nothing but 10 to the power of minus 10 meter, right? So everything has to be in SI unit, so I have converted Armstrong unit into the SI unit, right? Apart from this, what are the given data they have given you? They have given you the mass of the proton to be equal to 1.67 into 10 to the power of minus 27 kg, and mass of the electron is given as 9.11 into 10 to the power of minus 31 kg, okay, right? And we will be also using the value of G also, because we are going to compare electrostatic force and gravitational force, right? So for the gravitational force, we need the value of G, and the value of G I have already written it for you, but anyway let me write it in the given data also. So the gravitational constant capital G is equal to 6.674 into 10 to the power of minus 11 kg power minus 1 m cube s power minus 2, okay, right? So come on, let's start doing the problem. Let's find the solution for the problem, okay, right? So let's start with the A1 part, right? So for the A part, A itself has got two sections, 1 and 2, right? So for A, for the first Roman letter, that is between an electron and a proton, okay, right? So first of all, let's write the expression for the electrostatic force, right? That is your Coulomb's force, right? So what will be the expression for the Coulomb's force between this electron and a proton? That will be equal to 1 by 4 pi epsilon naught, okay, minus E into E, right? We know that electron is negatively charged, proton is positively charged, otherwise they both are same, right? And their masses will also be different, divided by R square. Okay, right? So now minus into plus will be equal to minus. So minus 1 by 4 pi epsilon naught E square divided by R square. Okay, right? Now we need the magnitude, right? We are going to compare the magnitudes only. So the magnitude of the electrostatic force will be, modulus of Fe will be equal to 1 by 4 pi epsilon naught E square divided by R square. Okay, we need only the magnitude, right? What is the significance of this negative sign here, children? It just says that, see, this is a negative charge and a positive charge, right? So the force will be attractive force. Okay, the force is going to be an attractive force. So just for stressing that point, they have used a negative symbol, or else I can just leave the negative sign and go ahead. So the magnitude of the electrostatic force will be equal to 1 by 4 pi epsilon naught E square by R square, right? Let this be the first equation for me. Now what I am going to do, I am going to write an expression for the magnitude of the gravitational force between this electron and this proton. Okay, right? So let's go ahead with that. So Fg, okay, right? Fg between an electron and a proton, okay, right? So Fg will be equal to, what's the formula? Minus G into gravitational constant G into mass of electron into mass of proton divided by R square, okay, right? Again, this negative symbol is just to say that this gravitational force will be always attractive only. Okay, attractive only. Okay, right? Now I need only the magnitude of this Fg. So the magnitude of the gravitational force will be equal to G into mass of electron, mass of proton divided by R square, right? Let this be the second equation for me. Okay, now what do we need, children? We need the ratio between Fe and Fg, right? So here is your Fe from the first equation, and here is your Fg from the second equation. So the modulus of Fe divided by modulus of Fg will be equal to, what was your Fe, children? Hope you remember, 1 by 4 pi epsilon naught E square divided by R square. And what is your Fg? Fg is G into Me Mp divided by R square. Okay. Now this can be rewritten as 1 by 4 pi epsilon naught E square by R square into R square divided by G into mass of electron, mass of proton. Now R square and R square will get cancelled off, right? So what else is remaining? 1 by 4 pi epsilon naught E square divided by G into mass of electron, mass of proton. Okay. Now we know all these values, right? All these values we know. So let's substitute all these values, right? So what's the value of 1 by 4 pi epsilon naught? That is equal to 9 into 10 to the power of 9 into, what is the value of each, children? If it might be a proton or an electron, charge of electron and proton will be the same in magnitude alone. So 1.6 into 10 to the power of minus 19 Coulomb, the whole square, the whole divided by the gravitational constant G. Am I right? So what's the value of gravitational constant? 6.674 into 10 to the power of minus 11 into mass of electron, right? So what is the mass of electron, right? All these values, see, all these values by now you should start remembering, okay, right? So even if you don't remember, start remembering, children. You have to by heart it, right? No other way. So mass of the electron, we know it to be equal to 9.1 into 10 to the power of minus 31 kg, and mass of the proton, right? And how much is the mass of the proton? Mass of the proton is equal to 1.67 into 10 to the power of minus 27 kg. Okay, right? Now if you calculate this, right, the calculation of this, all these values will give you 2.27 into 10 to the power of 39, and there will not be any unit, right? Because Fe by Fg, Fe unit is Newton, Fg is Newton and unit is also Newton. So, Newton cancels off. So, this is a unitless, right? No unit will be there for this ratio. Okay, right? So, from this what can I write, children? Magnitude of Fe is equal to 2.27 into 10 to the power of 39 times the gravitational force, right? Magnitude of the gravitational force, right? So, from this what can you conclude? You can conclude that the electrostatic force of attraction between electron and proton is very much greater when compared to the gravitational force between the electron and the proton. Okay, right? So, the first part for the A, first Roman letter is over, right? We have calculated the ratio of Fe by Fg for an electron and a proton. Okay. So, now what else is remaining in the A part? For the A part, I have to find the same ratio Fe and Fg between two protons, right? It will be similar to what we have proceeded now. So, A, second one, okay, A, second Roman letter, right? So, this is between two protons. This is between two protons, right? So, for the protons, the electrostatic force of repulsion, right? Both of them are protons. So, both of them are positive charge, means they both will be repelling each other. So, that will be equal to 1 by 4 pi epsilon naught E into E divided by R square. There will not be any negative symbol because here the force is not an attractive force. The force is a repulsive force, right? So, what will be the magnitude of your electrostatic force? That is going to be the same thing, that is 1 by 4 pi epsilon naught E square divided by R square. Let this be the third equation for me. Now, I will write the expression for the gravitational force of attraction between the two protons, and that is going to be G into mass of the proton into mass of the proton divided by R square, and the magnitude of this force will be equal to Fg, right? This is going to be a negative, right? This is going to be negative because you know that the gravitational force is always an attractive force only. Okay, right? So, this will be in negative sign only, but while considering the magnitude, this will become G into mass of proton square, okay, mass of proton square, the whole divided by R square. Let this be the fourth equation. Now, again let's find the ratio between magnitude of Fe and magnitude of Fg, right? So, what is Fe now, children? 1 by 4 pi epsilon naught E square by R square, the whole divided by G into mp square divided by R square, right? So, let me rewrite it. 1 by 4 pi epsilon naught E square by R square into R square divided by G into mp square. R square and R square will get cancels off, and you will be getting only 1 by 4 pi epsilon naught E square divided by G into mass of the proton, the square, right? Now, substitute the values. What's the value of 1 by 4 pi epsilon naught? 9 into 10 to the power of 9 into what's the value of charge of the protons, children? 1.6 into 10 to the power of minus 19 Coulomb, the whole square, the whole divided by G, right? What's the value of G? 6.674 into 10 to the power of minus 11 into mass of the proton, right? Mass of the proton, we know it to be equal to 1.67 into 10 to the power of minus 27, the whole square. Now, substitute everything. You will find this ratio to be equal to 1.24 into 10 to the power of 36. Okay, right? Again, no unit because numerator also Newton, denominator also Newton. Newton will cancel off, right? So, magnitude of Fe divided by magnitude of Fg is equal to this much. So, from this what can I say? Fe, magnitude of Fe is equal to 1.24 into 10 to the power of 36 times the gravitational force of attraction between the two protons, right? Here also the electrostatic force of repulsion is greater when compared to the gravitational force, right? Fg. Okay, right? So, this is for the two protons. Okay, right? So, now we have finished the first part, that is A part is over. So, for the A part, we have calculated the ratio of Fe by Fg for an electron and a proton and for two protons. Okay, children, right? So, what is the B part, right? Hope you remember the B part. Read the B part again. What is given? Estimate the accelerations of electron and proton, right? We have to calculate the acceleration of electron and proton due to the electrical force of their mutual attraction when they are 1 Armstrong unit apart. Okay, right? So now we have to calculate the acceleration of proton and acceleration of your electron. Okay, right? So let's calculate that. So this is your B part. Okay, B part, acceleration of the electron and acceleration of the proton is equal to how much? Okay, right? And what is given? The distance of separation between them is equal to 1 Armstrong unit, and that we know it to be equal to 1 into 10 to the power of minus 10 meter. Okay, right? So now see, this electron, see, there will be a force of attraction between this electron and the proton. Okay, right? According to Newton's third law, we know that this electron will be attracting the proton. Okay. Similarly, the proton will also be attracting the electron. Okay. Magnitude of these two forces, right? That then I can write that force of right? That is, what is this F E minus E? That is force on the electron due to proton. Okay, force on the electron due to proton. This is how you write the suffix for your Coulomb's vector form, right? Force on electron due to proton it will be equal in magnitude to what? Force on proton due to an electron, right? Force on proton due to an electron, right? They both will be equal in magnitude to each other. Okay, right? So for acceleration, we need to calculate the value of this force, because we are going to use your Newton's second law of motion, that is F is equal to m into A. So what will be F is equal, A is equal to, children, A will be equal to F by m, right? So now we have to find the value of F. Okay, right? So when we find the value of F, what's the formula for F? F will be equal to 1 by 4 pi epsilon naught electron into proton, right? Charge of an electron into charge of proton divided by the distance of separation between them, that is your r square, right? Now what is this equal to? 9 into 10 to the power of 9 into e square. E square will be equal to 1.6 into 10 to the power of minus 19 the whole square, the whole divided by r square, right? What's the value of r here? 10 to the power of minus 10 the whole square, right? Now what is the value of force, children? Force, mutual force will be equal to 2.3 into 10 to the power of minus 8 Newton. You can calculate it, it will be coming, right? Don't worry, I have already calculated, right? It will be coming, right? Now let's find out the acceleration, right? So first of all, let's find the acceleration of electron, right? Acceleration of electron due to mutual attraction with proton. Okay, so for this, acceleration of the electron will be equal to the mutual force divided by what? Mass of the electron. Okay, right? So acceleration of the electron, we have to consider mass of the electron only, right? So what this value F is found to be equal to 2.3 into 10 to the power of minus 8 divided by mass of electron, we know it to be equal to 9.1 into 10 to the power of minus 31, and this will be, you will be finding it to be equal to 2.5 into 10 to the power of 22 meter per second square. Okay, so this is the acceleration experienced by the electron. Okay, right? Similarly, acceleration of proton due to mutual attraction with electron. Okay, for that, acceleration of the proton will be equal to mutual force divided by mass of the proton. Okay, right? So mutual force is 2.3 into 10 to the power of minus 8 again, divided by mass of proton is 1.67 into 10 to the power of minus 27, and this value we find it to be equal to, acceleration of the proton, we find it to be equal to 1.3 into 10 to the power of 19 meter per second square. Okay, this is the acceleration experienced by the proton. Okay, right? Now if we compare the acceleration of the electron and acceleration of the proton, which one is greater, children? right? Which one is greater? Acceleration of the electron is greater, right? Acceleration of the electron is greater when compared to the acceleration of the proton. Okay, right? Why? Because mass of electron is less when compared to the mass of the proton, right? So that's why I say that acceleration of the electron is more when compared to the acceleration of the proton. Okay, right? So thus we have completed example 1.4. We have answered for the second part also, that is for calculating the acceleration, right? So for that also we have finished. So that's all for the example 1.4, children. Thank you. Okay, now we are going to see the example 1.5. Okay, right? So this also comes under the Coulomb's law only. So example 1.5, see, I have written the question. Read the question carefully. What's given? A charged metal. I have also drawn the diagrams down, right? I will show you, right? A charged metallic sphere A is suspended by a nylon thread. Okay, so see, this is a charged sphere, okay, charged metallic sphere A, which is suspended by a nylon thread. Okay, right? Another charged metallic sphere B, held by an insulating handle, is brought close to A such that the distance between their centers is 10 centimeter as shown in figure A, right? So this is your figure A, children. So what is given? This is your A sphere and this is your B sphere. The distance between the centers will be equal to 10 centimeter. Okay, A sphere is suspended with the help of a nylon thread, right? And B sphere is held by a handle. Okay, right? Insulating handle, right? So nylon is also an insulating one. Handle is also an insulating handle only. Okay, right? Now you know that both the spheres are being separated, right? Their resulting repulsion of A is noted, right? So A is being repelled by B. That's given, right? For example, by shining a beam of light and measuring the deflection of its shadow on the screen, right? They will shine a light over A, and when this A is moving, what will happen? The shadow of the shining will be moving over a scale, right? Horizontal scale. So from that horizontal scale, we can measure how much is moving, how much the sphere A is moving because of the repulsive force of B. Okay, right? So that's what they have given you. For example, by shining a beam of light and measuring the deflection of its shadow on a screen. Now, spheres A and B are touched by uncharged spheres C and D respectively as shown in figure B, right? So see the figure B, children. In the figure B, what is given? Now see, now this A sphere is touched by, this is your actually C sphere, not your B sphere, right? A sphere is touched by C sphere and B sphere is being touched by D sphere, right? C and D are uncharged. Okay, right? C and D are uncharged. So uncharged spheres C and D are touching the charged spheres A and B respectively. Okay, right? Then what is being done? C and D are then removed and B is brought closer to A to a distance of 5 centimeter between the centers as shown in figure C, right? So now what have they done in the third diagram? They have removed C and D. And what have they done? They have reduced, right? See in the first figure, the distance between the centers were 10 centimeter. Now they have reduced the distance between the two spheres to be equal to 5 centimeter. Okay, right? Between the centers as shown in figure C. What is the expected repulsion of A on the basis of Coulomb's law, right? The spheres A and C and spheres B and D have identical sizes. Okay. Ignore the sizes of A and B in comparison to the separation between their centers, right? So they have asked us to ignore the size of A and B when compared to the distance of separation between them. That is, they have asked us to consider A sphere and B sphere as point charges. Okay, right? So that's what they are telling us, to consider them as the point charges, right? So actually what is given in the question and what is asked, children? See, there are two spheres A and B pa. Both of them are identical in all respects. Initially, the distance of separation between them was 10 centimeter. Okay, they both are charged only. Okay, now what are we doing in the second diagram? A sphere is touched by an uncharged sphere C. Okay, similarly, B sphere is touched by another one uncharged sphere C. Now what will happen? Whatever was the charge of A after touching with this uncharged sphere C, what will happen? They both are metallic spheres, am I right? So the sphere A will give half of its charge to C. Okay, half of its charge to C, because A and C are identical in all respects, right? So when the both of them are having the same amount of charge, the charges will stop moving from A to C, right? Similarly, B sphere will also give its charge to D until both of them are having the equal amount of charge. Okay, right? So now what has happened in the B diagram? Half of A's charge has been given to C and half of B's charge has been given to D. Now in the third diagram, see, we have removed C and D, only A and B are left, right? So now what is the amount of charge? It is just half, right? Half for A and B, and the distance of separation between them is also halved, right? So now what is the force of attraction between those two spheres, right? So that's what they have asked you to find out. Okay, children, right? So first of all, let's write down the expression for the force of attraction, force of repulsion between A and B. Okay, right? So for that, so see, let me have the diagram, right? Let me show the diagram and tell you. So now initially, before touching with C and D, let us consider that initial, okay, initial charges of A and B, right? A and B, Q1 and Q2. Okay, initial charges of A and B is Q1 and Q2, right? And initial distance between them, initial distance between them is equal to R. Okay, right? Now after touching with C and D and leaving them like this, what will happen? Final charge of A, that is Q1 dash. Okay, right? So initial charge is Q1, means I am taking the final charge to be Q1 dash of A will be equal to what? Q1 divided by 2, right? It has been reduced to half the initial value, right? It has been reduced to half its initial value. Just a minute. Okay, right? Similarly, final charge of B, that is Q2 dash, will be equal to Q2 by 2, right? Now for both the spheres, after touching with C and D, the charges have been halved, right? Because they both are identical, so it will be reducing to half only. Okay, right? And what is the final distance between the charges? Final distance between them, let's take it to be equal to R dash, right? Now actually we know the value of R to be equal to how much? 10 centimeter, and R dash to be equal to 5 centimeter. Okay, children, right? So now what are we going to do? We are going to write an expression for the initial force, right? Initial force of repulsion between these two charges, right? These two spheres. So that let me write it as F, right? So F will be equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square, that will be equal to, right, let me write it as R square itself. Okay, children, right? Okay, now what will be your F dash then? F dash, what is F dash? F dash is the final force between the two spheres, that is final force between Q1 dash and Q2 dash. So F dash will be equal to 1 by 4 pi epsilon naught Q1 dash Q2 dash divided by R dash. Okay, right? So now 1 by 4 pi epsilon naught, what is Q1 dash, children? Q1 by 2. And what is Q2 dash? Q2 dash is equal to Q2 by 2, right? Divided by, how is your R dash, children? R dash is actually R by 2. Am I right or not, right? Initially the distance of separation between them was 10. Finally it is 5. It means that it has been reduced to half. So R dash is R by 2, right? So this is going to be R by 2 the whole square. Okay, right? Now what will have, how can I write it? 1 by 4 pi epsilon naught Q1 Q2 divided by 2 into 2 will be 4. Okay, the whole divided by R square divided by 4. Okay, right. Now I can rewrite this expression as 1 by 4 pi epsilon naught Q1 Q2 divided by 4 into 4 divided by R square. Okay, now what will happen? 4 and 4 will cancel off and I will be getting 1 by 4 pi epsilon naught Q1 Q2 divided by R square. And what is this equal to? Nothing but, see, nothing but your F. Okay, right. So this is equal to F, right. So F dash, we have found that F dash is equal to F, right. So when you touch the two spheres with an uncharged sphere C and D, and when you halve the distance between them, what is happening? The force remains the same. Okay, children, right. So this is example 1.5 for you. Okay, right. Hope you have understood. If you have got any doubt, you can ask me in the comment section. I will explain to you. Thank you.